Oh, I've lost him. All right, so we're looking at the distribution here. So it's in blue. So we press second, distribution. Okay, we want normal CDF. Okay, so because it's a shaded area all the way up to 0.56. So we press 2. Now, the lower is you want to be able to indicate a value over the side. We know it's to the left, so we know it's negative. Now, it doesn't need to be this. This is just defaults to that. And if you want to just put negative 1,000, if you're more comfortable, totally fine. Okay? Enter. Then our upper bound for this question would be 0.56 because that's the right-hand side of our shading. So lovely jubbly. Our mean is 0 because it's standard normal, and our standard deviation is 1. We hit paste. It pastes it into the formula or the program, and we get an answer of 0.712. How do we round answers, Jushna, when we're doing mathematics in SL? 3 significant figures. So this to 3 significant figures at Jushna would be
7.12. Oh, 0.712.
0.712. Obviously, stolen property doesn't have a light. So that would be our answer here. So down here, we would say 0.712. Okay, Tresbians? Next example. All right. Yes.
So say it was negative 0.56, and we'll find it again.
Just as a FYI, we're going through several different examples.
Oh, now I'm there.
All right, so we've now got Z is greater than negative 1.23. So what did we say we did? We're going to draw a line roughly where negative 1.23 is. Is it going to be on left or right? Left. Doesn't matter where. Negative 1.23. We want greater than that value. So where are we going to shade? Okay. We're now going to input that into our calcs. So we're always going to use CDF. Okay, so second distribution, number 2. Now this time, what's our lower going to be? Negative 1.23. Lovely jubbly. Is that what you were going to ask me, Shelves? Huh? Oh. Upper. What are we going to put for the upper? 1,000. Lovely jubbly. Mean doesn't change, standard deviation doesn't change because it's standard normal. Press paste. Oh, what have I done? Oh, did I use the takeaway sign? Oh. What did I say? Huh? So the probability for this bad boy is... Nice. 0.891. Oh, that goes in that space there. Okay. Next one. Yeah, we said that. Next one. What does this say, Camerona?
So Z is less than negative 0.8.
Good. Where are we going to write the negative 0.86?
Anywhere on the last side.
On the left side. Negative 0.86. Which bit are we going to shade?
The left.
Good. And we get our calculators. And we go to distribution. And what are we going to put for our lower? Be careful.
Negative 1,000.
Negative 1,000. Remember? Because our lower is now far left. Our upper, what are we going to put? 6 Tresbians. 0, 1, check. And our answer here is... Yeah, I'm hearing it. 0.195. Obviously, if they wanted this as a percentage, what would you do with that decimal? Multiply by 100. Good. All right, sometimes they want the probability between two values. Okay, so you've got 0.4 and 1.83. Remember, when our arrows are pointing in the same direction to the left, we're talking about in between those two numbers. Yeah. Yeah, I mean, to be honest, I would always leave it as a decimal myself, unless they specifically said percentage. Okay. So where are my two numbers that I'm going to be writing here now? But upper and lower are both on the right. Yeah. So 0.4 and 1.83. As I said, these diagrams don't have to be superb. Really, nothing needs to be to scale. It's just to get you to visualize roughly how much you're looking at. So we know that when we're looking at getting our answer here, we know it's got to be less than 50%. Yes. So if for some reason you stick in your information and you get 0.79, you've done something wrong. Okay. So always I want you to be thinking, what is this sensible? So this second lower. What's my lower? 4, and my upper. Lesbians. La la la. What do we get? 0.311, yeah. Awesome. Alright, so many questions can be answered now using the GDC without converting them. But as I said, I would still just do a little sketch to determine if it's roughly correct. So this is our question. The random variable x, n, so n tells us it's normally distributed. So from this original question, we need to establish the two bits of information we need. So which bits of information does it tell us? What's the value of the mean? 10. And what's the value of the standard deviation?
2 squared.
It is just 2. Okay. Remember, sometimes they will write it as the variance, so it will say 2 squared, but the information we need is just the 2. Yes, you're happy with that? Okay. So that's the first thing. So here we go. Here's our little sketch. I copied it from the book, a little bit rascalish. So I've got my sketch. My mean is 10, so my 10 is in the middle. They're saying between 9.1 and 10.3. So 9.1 is on the left of 10. Okay, so this value here is representing 9.1. This is representing 10.3. And so that's what we're going to type into our calculator. I've shown that for you on this screen thing here. So lower is 9.1, upper is 10.3. But this time we do need to change the mean and the standard deviation. Okay, so it's 9.1, 10.3. Our mean is this time 10, and standard deviation is 2. And you'll get that? 0.233. Yeah? Did someone just go, Eggs laid by a chicken are known to have mass normally distributed with a mean 55, standard deviation 2.5. What's the probability that an egg weighs more than 59? Okay, so we're going to draw a little sketch. Takes 2 seconds. Lovely jubbly. Our mean is 55 and our standard deviation is 2.5. So I know that here in my calculator I'm going to have 55 as my mean and 2.5 as my standard deviation. And I want to know the probability it weighs more than 59. So where is 59 on my on my graph? To the right. And I want to know more than, so where am I going to shade? To the right. Okay, now the only thing here is that, so what's my lower going to be? 59, yeah. Now, your upper, We used 1,000 before, and I'm sure 1,000 will give us the correct answer. But as these numbers here change, you need to make sure that it is substantially bigger than those ones. Do you see what I mean? So when this was 0, 1,000's plenty big enough. When it's 59, obviously it's much bigger than it, but perhaps I'd put maybe 10,000 or 1,000,000 because my numbers are now getting bigger. Do you all understand what I mean by that? As I say, I'm quite sure that you get the same value, but just put some number of zeros on the end and let's hope we get the right answer. Oh, we're at 10 minutes. We will get the right answer. I'm going to stop. Never going to know.